Okay. Papa.
Yes, Giuseppe.
Marcus needs 2.5 liters of the sauce.
The sauce.
The sauce.
Marcus wants the sauce. I'll give him the sauce. Giuseppe, this is the recipe. You take the secret ingredient. You shake it up. You do 0.75 of this. Now, we take the other special ingredients, and it's 25%. And there's the sauce. But you gotta always make sure the sauce is right. Perfect.
It's 30 miles, Papa.
Well, then we've gotta go.
Whoa! Did you bring me my
got
sauce?
your sauce.
Oh.
Papa, that might have been our fastest time yet.
Well, Giuseppe, with the wind, it only takes us about 45 minutes.
I got my sauce.
You got the sauce. Here you go. I hope this party gets lit.
About to make some chicken.
Papa, what do you think our rate was?
That's for Mason.
Wow, Papa, that wind was so fast it took your apron off.
Crazy road, Giuseppe. A lot of smells.
How fast do you think how fast do you think that wind was? Like,
I mean,
that trip was a long time.
I don't know, but I think we could definitely calculate it, because I know the trip took us about 81 minutes.
Hello, it's me, Spagano with Khan Academy, and today we're going to do some math. So the problem today is Dennis needs to deliver the special sauce to his best bud's Bumping Bash over at 24 Hick Street. Marcus says he needs 2.5 liters of the special sauce for his Unreal Barbecue. Dennis concocted the sauce through two secret mixtures, which are 25% and 75% of the secret ingredient. Dennis needs a 50% solution to make the special sauce. Once Dennis makes the sauce, he has to send it to Marcus's BBQ via air transport. The 30-mile trip there took 3/4 of an hour with the wind. It took 1.35 hours on the way back against the wind. Figure out the speed of the air transport and the wind, along with how many liters of each secret ingredient goes into the special sauce. Now over to the special kitchen. Now that we've seen the equation in real life, we're going to do some math. So we know that both of the solutions combined will be 2.5 liters, which is the amount that was ordered. We also know the 25% concentration of one sauce plus the 75% concentration of the other sauce will equal the 50% concentration of the 2.5 liters. And now these will be our equations to solve it. Good.
Now that smart guy Mason's broken it down for us, we're going to look at this from a fundamental standpoint. We got our two equations, and what we're going to do is use elimination to eliminate the x from the equation. We're going to multiply it by negative 0.25 so that the x's will cancel out. From here, once we do the math, we come down with 0.5y equals 0.625. And then, by dividing by 0.5, we're able to get y equals 1.25.
Thanks, Connor. All right, so now that we have y, we plug it in for this. So you just do x plus 1.25, aka y, equals 2.5. Then you subtract the 1.25 from 2.5. You get x equals 1.25. Boom. And then, wait, we got to check our work. 1.25 plus 1.25 equals 2.5. And 2.5 equals 2.5. So now x equals 1.25 and y equals 1.25.
All right, so thanks, Xavier, for that wonderful explanation. But now we're going to move on to our two equations that will help us find the rate of the air, the wind traveling towards Dennis and with Dennis, and the rate of Dennis as he's traveling through the air. So when Dennis is flying with the wind on his back helping him, the equation starts off as distance equals rate times time, but then we got the distance, 30 miles, the rate we don't know yet, and 3/4 of an hour, which is also 45 minutes. So when we solve that through, you just multiply by 4/3 on both sides, and you get the rate of one, which is with the air. You get 40 miles an hour. Then for the second one, when he's going against the wind, we still have distance equals rate times time. This distance, still the same, 30 miles. And then the rate, we still don't know, but 1.35 is the time because it takes that long, or 81 minutes. When we solve that through, you're just going to divide 30 by 1.35, and you get the rate as 22.22 repeating. Now, we're going to solve those equations. So now we have rate, the rate is 40 miles for the first one, and the rate is 22.22 repeating for the second one. So what we're going to do is subtract the lesser from the greater and then divide by 2, and that's how we're going to find the speed of the current. So we do that, 40 minus 22.22 repeating, and you get 17.77 repeating, and then you divide that by 2, you got 8.88 repeating, and that is the speed of the current. Now to find Dennis's speed, we're going to subtract that from the largest rate, which is when he's going with the wind, and when you do that, you get 31.11 miles per hour repeating, and that's Dennis's speed. So yeah, that's what we got here.
Let's hand it off to Mason.
Let's do it.
Now that we have reached the end of the presentation, here are the answers. You will need 1.25 liters of the 25% ingredient. You will need 1.25 liters for the 75% ingredient. The wind speed is 8.88 repeated miles per hour, and Dennis's speed is 31.11 miles per hour.